In this lab, we are going to configure multi-area OSPF. I have already pre-configured the IP addresses for the interfaces and enable them. I have written the prefixes and the IP addresses to the topology map. We are going to configure the areas according to this topology. R1 and R2 are going to be ABRs or area border routers because they touch both the backbone area and a non-backbone area, and they will maintain two separate LSDBs. R4 is going to be an ASBR, and we will see how we can inject routes from another routing protocol into the OSPF domain. So let's start. First, we are going to establish the adjacency between R1 and R2. I haven't done that in the initial configuration, but we are going to create loopback interfaces on each router, which will also serve as router IDs for OSPF. So interface loopback1. And the loopback addresses are going to be the same for octets as the router number. So 1.1.1.1 in this case, just to be able to identify them easily. And the network mask is going to be /32. And we are doing the same thing for R2. Interface loopback0, IP address 2.2.2.2 and /32. We have several methods to enable OSPF on an interface. First, we are going to use the network statement. So let's start the OSPF process with the process ID of 1. So router OSPF 1. And by the way, the process ID is only locally significant. So this does not have to match with the neighbor's process ID to form an adjacency. So the network statement works the following way. Every interface which falls within this address space is what we're going to advertise over OSPF. So for example, if I say network 1.1.1.1 0000 area 0, with this statement, we explicitly say that we want to have OSPF enabled only on this 1.1.1.1 /32 IP address. So this 0000 is the inverse or wildcard mask. This really means 255.255.255.255, which is /32. And we want this interface, which is our loopback interface, in area 0. Similarly, let's configure another network statement. So network 10.0.0.0.255 area 0. So this one means that every interface which has an IP address within this address space, which is 10.0.12.0/24, should enable OSPF and participate in area 0. So again, this does not mean that we are advertising this network. So this works very differently than BGP, for example. So this statement should effectively enable OSPF on G G00. And one more thing, it's usually good practice to make the loopback interface passive interface. So passive interface loopback 0, which means that we don't want to send hello messages out of this interface, and we don't want to form adjacency with this interface. But still, we want to advertise the loopback address, and we want that other routers know about this 111 network. We are done with R1 so far. Let's move on to R2. And I have already started a packet capture in the background between R1 and R2. So we can take a closer look at the packet flow. We have already started sending hello messages every 10 seconds to the multicast address 224005, but there is no answer from the other side just yet. So on router 2, this time we are going to enable OSPF with an interface command. On loopback 0, we are going to say IP OSPF process ID 1, which again only locally significant, area 0, and for G0/0 as well, IP OSPF 1, area 0. And this time the area number has to match with the neighbor as well. We could place loopback 0 into area 2, doesn't really matter, because only G0/0 is used to form an adjacency. And the neighbor relationship has been established successfully according to this log message. So to show IP OSPF neighbor, we have a designated router and a backup designated router on this link, which is not really necessary in this case, but we are using the broadcast network type by default since these are Ethernet links, and we are using the multicast address 224005 to establish the neighbor relationship. They are exchanging several packets, database descriptions, link state requests, and type 1 LSAs, which are the basic building blocks to create a link state database. And I think we should have one type 2 LSA. And according to this packet, 1.1.1.1 should be the designated router on this link, because only the DR creates type 2 LSAs, which is true according to this show command. And at the end of exchanging LSAs, they will have an identical link state database since they are in the same area. Let's make loopback 0 a passive interface here as well. So router OSPF 1, passive interface loopback 0. And let's establish the adjacency the same way between R2 and R3, and between R1 and R4 as well. So let's start with this link. So on router 2, we have to place G0/1 into area 2. So interface G0/1, IP OSPF 1, area 2. Move on to R3. We create a loopback address, so interface loopback 0. And advertise this address with OSPF, IP OSPF 1, area 2, and the IP address of G0/0 interface. and we have established the neighbor relationship. I'm gonna make loopback 0 a passive interface just to be consistent with the other routers. And if I switch back to R2 and issue show IP OSPF neighbor, we can see that we have two neighbors and reach the full state with each of them, which is what we want to see in a broadcast network. So only area 1 is left. So let's switch to R4 and create a loopback interface. And I'm gonna use the network statement this time. So network 4444 and define the exact address with a /32 network mask. And we want this interface in area 1. And for G0/0, let's use the /30 network mask, which is what we have on this interface. So network 10.0.14.0.0.0.3 and area 1. Again, we are not advertising this address. We are advertising every IP address which falls within this address space, which is only G0/0 IP address. And let's enable OSPF on the other side as well. So on R1, I'm gonna use the interface command here. So interface G0/1 IP OSPF process ID 1 in area 1, and we have a neighbor relationship established, and we should have two neighbors here. So show IP OSPF neighbor. So we have both in the full state. So we have exchanged LSAs, and we have the same link state database in area 1. So now let's take a look at the routing table or the rib of R1, for example. So show IP route. And we have learned several routes via OSPF. So we have both intra-area route as well as inter-area route. The intra-area routes are in the same area. So for example, 2.2.2.2 is in the same area as R1, but R3's loopback address is in a different area, area 2. So this IA indicates that this is an inter-area route. So now we should have full connectivity within this routing domain. So for example, from R4, let's ping R3's loopback address, so the far end router. So ping 3.3.3.3, and the ping was successful.